Hey guys, these notes are for solving quadratics using square roots. It is the third way we learned how to solve quadratics. The first way we learned was to solve by graphing, the second one was to solve by factoring, and then this one's to solve by using square roots. And so every time we're solving a quadratic, remember we're always looking for the solutions, which means we're looking for the x-intercepts. Okay, so just keep that in mind. Every time we're solving and we get x by itself, it means we have found the x-intercept. All right, so our essential question is when and how do we solve quadratics? So there are certain methods that are easier than others, of course, like graphing probably isn't like on the top of your list for easiest method. But let's just talk about standard form for a second. So standard form, remember, is ax squared plus bx plus c equals 0, okay? Now, why do I have it equal to 0, not equal to y? Because it's an equation, right? Well, the reason why I have it equal to 0 is because I'm looking for the x-intercepts. And so I need my y equals 0, or equal to 0, okay? When we're solving by square roots, that means that we have b equal to 0. So we solve by square roots when we have b equals 0, so that means that b term, that middle term, is not even there. Meaning, I just have ax squared plus c equals 0. So if there is not a b term, you are okay to use square roots. But if you have a b term, go ahead and factor or graph. Do some other method, but square roots won't help you for that one, okay? Now, our goal here is to isolate something. Now, when you're normally solving an equation, you're always trying to get what by itself? You probably said either x or a variable, right? You're always trying to get your x or your variable by itself. Well, in this case, I'm trying to get my x squared by itself, okay? And so in order to get rid of an x squared or something squared, I have to do something that will undo that process. So to undo a square, I'm going to take a square root. Right? Like if I had 9 squared and I got 81, to undo that, I would square root it and get 9. Okay? So let's go ahead and begin with number 1. Again, we want x squared by itself, so the first thing I'm going to do is subtract 3 on both sides. And then after I do that, I want to get rid of that square, right? I want x by itself. So in order to get rid of that, I'm going to square root. And you're like, why? Well, the square root and the square, when they're together, they cancel each other out, okay? It's kind of like if you have a plus 3 and then you take away 3, they cancel each other out. So since it cancels it out, I just have an x left over. And then I take the square root of 9, and the square root of 9 would be 3. Now, what does it mean for the square root of 9 to be 3? It means that 3 times 3 gives me 9, correct? Now, here's the issue. Is there another number that I multiply by itself to also get me 9? And the answer to that is yes, there is another number, negative 3. Is it negative 3 times negative 3 positive 9? Yeah. So you also have a solution of negative 3. So these would be your two answers, your two solutions. Now you're like, what? Okay. So let's pretend we had to graph this. So I'm going to go ahead in the red. You don't have to write what I'm writing in red. So I'm going to write this over here. So I'm going to write what I had. Now if I ask you to graph this to check, what would you do? Well, in order to graph something, I need it set equal to 0. And I always want to keep my a term positive. So I'm going to subtract 9 on both sides. And I have x squared minus 9 equals 0. Okay? Now I'm going to go graph that in Desmos really quick for you. You can graph it in your graphing calculator if you'd like. So I have x squared minus 9. Okay? And so remember, when we're looking for solutions, we're looking for the x-intercepts. I'm going to tap on those really quick, and I get negative 3, 0, and 3, 0. Those are the answers I got over here. I got negative 3 and 3. So you're looking for the solutions. That's what you're solving for. Okay? Go ahead and erase that. Another way to write this, if you want to write it a different way, you could also write x is equal to plus or minus 3, positive or negative 3. Okay? Two solutions when you square root. So this star here is to make an important note. When you take a square root, you have how many solutions, right? If I take a square root, if I square root 9, how many solutions did I get? You have 2. Okay? So you're always going to have 2 solutions. And that's mostly because you don't have a b term. You're either going to have 2 solutions or no solution. You can't have 1 solution in this case. All right, so let's go ahead and try number 2. First thing I'm going to do here, again, I want that c squared by itself, so I'm going to add 4 to both sides. okay? Now, the reason why I didn't divide by 3 first is because, remember, you do PEMDAS backwards. So you're going to add or subtract before you multiply or divide. The next step here would be to divide by 3, because you want the c squared by itself. So you have 16 equals c squared. Okay? Now, in order to get rid of that square on the c, I need to square root both sides. Okay? And I have c equal to 4, but c is also equal to negative 4. Okay? So you have 2 solutions here. You can have positive 4 and negative 4. Now, how can you check? You can literally plug it back in for your c value and check. You can also write c equals plus or minus 4, or you can write c equals negative 4 and positive 4, the set of those two things. There's lots of ways to write it, but you need to pick one. If I'm going to be honest with you, I would definitely pick these, the one where you write them separately twice, because it will help you make less mistakes when we get to more complicated stuff. So I would recommend you write it separately as 2 different solutions rather than plus or minus. All right. Let's move on. Number 3. So number 3, x squared is already by itself, so I'm good. All I really need to do is square root. And if I square root this, what happens? I get an error. It says unreal answer in your calculator. If you try that, go ahead and try that if you have a calculator. You can actually try it on even your iPhone, because I can try it on my phone right now. Let's see what it'll say. Oh, I have to rotate my phone. I'm not going to do it. It's probably going to give me like error or like something like that. All right, so it's unreal answer. So in that case, I actually have no solution. Now, why do I have an unreal answer? Because you cannot square root a negative number. It is not possible yet. You'll know how to do that in Algebra 2. But in Algebra 1, we don't really worry about square rooting a negative. So let me go ahead and graph this actually. So if I wanted to graph this, again, when I'm writing in blue, you don't have to write. If I wanted to graph this, I need it equal to 0. So I'm going to add 81 to both sides. X squared plus 81 equals 0, right? So I'm going to graph that in my Desmos really quick. Plus 81. And let's zoom out. Zoom out, zoom out. Okay, so my quadratic is all the way up there. Now, our answer was no solution, and that makes sense because solutions are x-intercepts, and this clearly doesn't have any. It's nowhere near the x-axis. It's like 80 units above. So, no solution. All right, number 4. Now this is getting into our more like tricky problems. So the first thing you're going to do here is you're going to add 10 to both sides. Negative 5r squared equals negative 160. The next step here is to divide by negative 5 because you want your r squared by itself. R squared equals, what is that? I think it's 32, but I honestly cannot remember. Yeah, it's 32. Now, you're probably looking and like, well, next step I would normally do is what? Take square root. So I'm going to take the square root. What's my issue here? The issue is 32 is not a perfect square. However, I can still simplify a square root of 32. So let's look over here on the left first. So when I square root that r squared, the square and the square root cancel each other, so I just have an r left over. Yeah, I'll do that in pink. And I know there's an equal sign. And anytime I square root a number, I'm going to have a plus or minus, right? I'm going to have plus or minus square root of 32. Now, if you circle that answer, technically, yes, it is correct. But it is not simplified completely, and I want you to simplify completely. So I'm going to go over here, and I'm going to simplify square root of 32. Okay? So let's simplify this. I'm going to pick 8 and 4. Those two numbers multiply to make 32. If you haven't watched the Simplifying Radicals video, or if you weren't in class for that, you do need to watch that because this is not going to make any sense to you. I'm going to keep going. And then I'm going to keep going here. All right, so I have 2 pairs. Whoops. And I have 1 lonely child. So that means my radical is 2 times 2 square root of 2. 1 for each set of parents, right? And then we have 4 square root of 2. So that means that square root of 32 and 4 square root of 2 are equivalent to each other. So my answer is actually r equals plus or minus 4 square root of 2. Okay? So So I'm just making it equivalent. So this would be our actual answer. Again, I do prefer that you write it separately. I mean, it's obviously up to you. But there are times where you do need to write it separate. And I will show you when. But again, it's just easier if you just write them separately always. Okay? Let me draw like a little arrow here. Whoops. All right. So, number 5. The first thing I want to talk about is the fact that something looks a little different. We have parentheses, right? We have x minus 2 squared. Now, you're not going to treat it any differently just because there's a parentheses there. So, for example, okay, what I just wrote over here is literally the same thing as I wrote over here, except instead of the x minus 2, I just have an x, okay? So everything is the same. In this instance, what would be the first thing that you would do? The first thing you would do is you'd add 2, correct? Well, you do the same thing over here. You'd still add 2. Don't distribute. That will just make your life harder. Okay? And then at this step, let's see, for example, you did this and you got 2x squared equals 16, right? Well, at that step, what would you do? Well, at this step, I would divide by 2. We're going to do the same thing over here. You're going to divide everything by 2. Okay? So those cancel, and you have x minus 2 squared equals 8. Okay? So nothing is different so far. You do the same exact process for everything. Now that you have something squared, right, we have this thing to the power of 2. That's the same thing as saying x squared because you have something to the power of 2. So now you're going to get rid of that 2, this little square, and you're going to square root both sides. Okay? Now you can't square root until you have that thing squared by itself. So you want the something squared by itself before you do any type of square rooting. All right. The square root and the square cancel each other out, so all I have left is x minus 2. And this will equal, again, when we square root, we always have 2 solutions. So this will be plus or minus 8. Okay? Now here, you could simplify the square root of 8 first, but I'm going to go ahead and add 2 first. So I'm going to add 2 to both sides. And so I have x equals, now here's the part where I'm picky about how you write this. I do want you to write the 2 in the front rather than in the back. And here's the reason why. Sometimes we have bad handwriting. So in the orange, I'm going to write an example. So let's say if you write it in the back, right? Some of us have bad handwriting. And I can't tell if your square root, if that plus 2 is included in the square root, or if it's outside the square root, or if it's just like some weird attachment to it. So I prefer that you write the 2 in the front just so that it's very clear to me where that 2 is supposed to be. It's kind of the reason why we don't write x3. We write 3x, right? x3, I can't tell if that's an exponent because sometimes your handwriting, I honestly can't read it. So it's just the same reason. So I prefer that you put that number in the front of your radical. Okay? Now I'm going to move this up here. So I have x equals 2 plus or minus the square root of 8. Now at this step, you'd be like, well, I'm done. But you always want to check, can you simplify your square root? And so I'm going to check that. So I have the square root of 8, and I'm going to simplify this. So I have 4, 2, and then 2, 2. And then you always want to look for pairs. And if you have pairs, then that means you can simplify. If you don't have pairs, then you can't simplify, okay? I have one pair, and I have one child. So that's going to be 2 square root of 2. So literally, everything is going to stay the same over here. The only thing that is different is that I simplified square root of 8 and made it 2 square root of 2. So that's the only difference. So everything in baby blue that I copied down is the same except for the dark blue stuff. Now, here's a step where I would like you to write stuff twice because you double check yourself to see if you can combine anything. Now, what does that plus or minus mean? That means I have 2 plus 2 square root of 2, and then I have x equals 2 minus 2 square root of 2. Again, we're solving for x-intercepts. So when you graph this on your calculator or on your or in Desmos, you'll get these answers for those x-intercepts. Now you always want to write it twice like this or write it split up because you do want to check, can I combine these? And in this case, the answer is no, I can't because I don't know how to combine a whole number and a radical together. It's not possible. So these would be my answers. Okay? So I prefer that you split them up for stuff like this. Number 6 is where it really matters if you split it up or not. So let's go ahead and try number 6. If you think you got it, go ahead and try it on your own, but I will begin it very shortly. Okay, first thing I'm going to do is I'm going to subtract 9. So same process that we've been doing, same process as number 5 so far. That's going to be 144. Divide everything by 4. So we have x plus 3 squared equals, oh, why does my mouth like keep making that whistling noise? Kind of creepy. Okay, equals 36. Okay, so at this point, I'm going to take the square root because I have something squared and I can get rid of that. It's all by itself. So I'm going to square root both sides. And again, when I square root, that x plus 3 just pops out. Everything else cancels over there. And square root of 36 is actually a perfect square. What's that number? Positive 6, right? But what are we forgetting? Remember, when we square root, we always have 2 answers. So it's plus or minus 6. Now here's the part where you need to write it twice. So let me move this over here. I have x plus, I don't know why I'm writing in purple. Let me make this green. All right, so over here I have x plus 3 equals plus or minus 6. And then now I'm going to get x by itself because it's not by itself yet. I'm going to subtract 3 on both sides. So I have x equals, now again I'm going to put that negative 3 in the front just so it's clear to me and I get used to that habit, plus or minus 6. So all I did was write that in the front. Now here's where I want us to split it up. Okay, so technically I have x equals negative 3 plus 6. And I also have x equals negative 3 minus 6. Okay, now in this instance, I can actually combine like terms here. This is why I want to write it twice. So I always want to double check if I can simplify any further. So over here on the left, I have x equals negative 3 plus 6. Well, I can combine negative 3 and 6, and that gives me positive 3. So I have x equals positive 3. But over here, I have x equals negative 3 minus 6, which is x equals negative 9. Okay, so I have 2 different solutions for this one. So if I were to graph this on Desmos or on your graphing calculator, you'd get an x-intercept of 3, 0, and an x-intercept of negative 9, 0. Okay? So that's one of those, like, put a star next to it because that one is a little bit extra you have to do. And then lastly, 7, we're going to do the same process that we've been doing. We want x squared by itself. So the first thing I'm going to get rid of is I'm going to add that 5 to get rid of the 5 over there. X squared plus 7x equals 7x plus 90. Okay? And since x squared is still not by itself, I'm going to subtract 7x on both sides. X squared equals, now what happens to my 7x's? Well, they both cancel, and I just have x squared equals 90. At this step, I have x squared all by itself. I have something squared by itself, so I can square root. And when I square root, I know I'm going to have an x equals. And I know when I take square root of 90, I'm going to have 2 answers. So I know I'm already going to have plus and minus. So I'm going to get that ready. And over here, I'm going to simplify the radical of 90. It's going to be 9 and 10, 3 and 3, 5 and 2. All right. So I have 1 pair, and I have 2 children here. So I have 3 square root of 5 times 2, which is 3 square root of 10. So that is going to go, let me make that a different color actually. So orange. Okay, so I'll make that orange. And then, so that is going to go here in place of the square root of 90 because I simplified it. Okay, so that is my answer. Or if you want to write it as 2 separate answers, you can write 3 square root of 10 and x equals negative 3 square root of 10. So you have 2 answers here. Okay, you can write it either or. I do not really care, obviously, but remember, in number 6, it did matter if we split it up. But that is it for our notes for solving by square rooting. Just need the x squared by itself or something squared by itself, and you just do normal process of solving equations. If you have any questions, feel free to email me or